this video, we'll be discussing questions from the final section, that is decimal representation of rational numbers in terms of terminating or non-terminating repeating decimals. The questions asked from this section are usually for 1 mark. The first question was asked in 2009. Series details have been provided for your reference. The question is, the decimal expansion of the rational number 43 by 2 raised to 4 into 5 cube will terminate after how many places of decimal? It's a 1 mark question. So the number given to us is 43 by 2 raised to 4 into 5 cube. So the rule is that a rational number, when expressed in p by q form, if the prime factorization of the denominator has only 2 and 5, then it has a terminating decimal representation. So this number will have a terminating decimal representation. Now we need to find how many places of decimal it will have. The easiest way to do this is to convert the denominator into powers of 10. We know that 2 into 5 is 10, but we have 4 2's and 3 5's here. So to equate the powers of 2 and 5, we need to multiply the denominator by 5. So let's multiply the denominator by 5. When you are multiplying the denominator by 5, you have to do the same for the numerator. So we've multiplied the numerator and denominator by 5. Now let's simplify this. 5 3's are 15, 5 4's are 20, 21, and the denominator becomes 2 raised to 4 into 5 raised to 4, which is 215 by 10 raised to 4. So here the denominator is 10 raised to 4, which means it will have 4 decimal places. So the number of decimal places is equal to 4. So they've given us a rational number in p by q form. Since the denominator q has only 2 and 5, it's a terminating decimal. To find the number of decimal places, you have to convert the denominator into powers of 10. To do this, you have to equate the powers of 2 and 5. Here we have 4 2's and 3 5's. So we need to multiply it by 5 in the denominator. We do the same for the numerator. And this gives us 10 raised to 4 in the denominator, which means it will have 4 decimal places. The next question was asked in 2010. Series details have been provided for your reference. The question is, has the rational number 441 by 2 squared into 5 raised to 7 into 7 squared a terminating or non-terminating decimal representation? It's a 1 mark question. So we've been given a rational number in p by q form, and we have to find if it will have a terminating or a non-terminating decimal representation. So the condition for a rational number to have terminating decimal representation is that when it is expressed in p by q form and its denominator q is prime factorized, the prime factorization should only have 2 and 5. But here we have an additional 7. So let's check. By factorizing 441, if we can cancel out the 7 square. So the number given to us is 441 divided by 2 squared into 5 raised to 7 into 7 squared. So now let's try factorizing 441. 2 will not divide 441. So let's try with 3. 3 1's are 3, 14, 3 4's are 12, 21, 3 7's are 21. Again, let's try dividing by 3. 3 4's are 12, 27, 3 9's are 27. 49 is 7 squared, so 7, 7. So we get the factorization of 441 as 3 squared into 7 squared by the denominator is 2 squared into 5 raised to 7 into 7 squared. So you can see 7 squared in numerator and denominator gets cancelled. So the number becomes 3 squared by 2 squared into 5 raised to 7. So now we have only 2 and 5 in the denominator. Therefore, it's a terminating decimal. So the rule is that a rational number, when expressed in p by q form, if the prime factorization of the denominator has only 2 and 5, then it will have a terminating decimal representation. But here we have 7 square additionally. So we first try factorizing the numerator and we see that it cancels out the 7 square in the denominator. So now we have only 2 and 5 in the denominator. Therefore, the number has terminating decimal representation. This question was asked in 2019. Series details have been provided for your reference. The question is, find a rational number between root 2 and root 3. It's a 1-mark question. So we have to find a rational number between root 2 and root 3. If you know the values of root 2 and root 3, you can do this directly. That is, root 2 is equal to 1.414 and so on. Root 3 is equal to 1.732, so on. So any rational number between 1.414 and 1.732 can be the answer to this question. For instance, we can choose the number 1.525. In case you don't know the exact values of root 2 and root 3, we can find a rough estimate of the value. So root 2 and root 3 lie between the perfect squares 1 and 4. So the nearest perfect squares to root 2 and root 3 are 1 and 4. The square root of 1 is 1, the square root of 4 is 2. So the value of root 2 and root 3 has to lie somewhere between 1 and 2. To find a more precise range, let's choose the midpoint 1.5. The square of 1.5 is 2.25. So root 2 will lie somewhere in between 1 and 1.5 and root 3 will lie somewhere in between 1.5 and 2, which means 1.5 will definitely be a number between root 2 and root 3. Why? Because root 2 is less than 1.5 and root 3 is greater than 1.5. Therefore, 1.5 can be chosen as a rational number between root 2 and root 3. So if you know the values of the square roots, we can do it directly by using a value between the square roots. If you do not know the exact value, you can do it using an estimation. So find the perfect squares closest to the number. So the square root will lie within this range, and check with the midpoint to find a more precise range and find a rational number between the two values. This was also asked in the same year in a different zone. Series details have been provided for your reference. The question is, find after how many places of decimal the decimal form of the number 27 by 2 cube into 5 raised to 4 into 3 square will terminate. It's a 1-mark question. So we've been given a number in P by Q form and we have to find after how many decimal places it will terminate. So the number given to us is 27 by 2 cube into 5 raised to 4 into 3 squared. So for a rational number to have terminating decimal representation, the prime factorization of the denominator should have only 2 and 5. But here we have 3 additionally. But we can see that 3 squared 9 will cancel out 27. So this will give us 3 in the numerator. So the fraction becomes 3 by 2 cube into 5 raised to 4. So now we have only 2 and 5 in its denominator. Therefore, this number will have a terminating decimal representation. The next step is to find the number of decimal places. To find the number of decimal places, the easiest way is to convert the denominator into powers of 10. For this, we know that 2 into 5 is 10. So, let us equate the powers of 2 and 5. We have 3 2's here and 4 5's. So, we need an additional 2 here. So, let's multiply the denominator by a 2. So, since we are multiplying the denominator by 2, we have to do the same with the numerator. So, this becomes 6 by 2 raised to 4 into 5 raised to 4. So, this can be written as 6 by 10 raised to 4. So, you have 4 tens in the denominator. Therefore, the number of decimal places will be equal to 4. So here we've been given a number in P by Q form and we have to find after how many decimal places it will terminate. First, we have to make sure the denominator has only 2 and 5. So here 3 square cancels out with the numerator and now the denominator has only 2 and 5. The next step to find the number of decimal places is to convert the denominator into powers of 10. To do this, we have to equate the powers of 2 and 5. We need an additional 2 here. So we multiply the denominator by 2. So we also have to multiply the numerator by 2. We get 6 by 2 raised to 4 into 5 raised to 4. 2 raised to 4 into 5 raised to 4 becomes 10 raised to 4. So which means it will have 4 decimal places. This was also asked in the same year in a different zone. Series details have been provided for your reference. The question is, find a rational number between root 2 and root 7. It's a 1-mark question. So here we have to find the value of the square root of 2 and 7 and then find a rational number between the two values. So the square roots can be found using the division method. But here, since it's a 1-mark question, we can estimate the values of the square roots and find the rational number between them. So let's start with the first number, root 2. The first step is to consider the perfect squares closest to 2, less than and greater than 2. So the perfect square less than 2 is 1 and the perfect square greater than 2 is 4. Now what is the square root of 1? It's 1. Square root of 4 is 2. Therefore, square root of 2 will lie somewhere between 1 and 2. To be more precise, let's consider the mid value, that is 1.5. The square of 1.5 is 2.25. 2.25 is greater than 2. Therefore, the square root of 2 will lie between 1 and 1.5. Let's do the same for root 7. So the perfect square closest to 7 and less than 7 is 4 and perfect square greater than 7 is 9. Square root of 4 is 2, square root of 9 is 3. So the value of root 7 will lie somewhere between 2 and 3. Now let's consider the midpoint, which is 2.5. Square of 2.5 is 6.25, which is less than 7. Therefore, root 7 will lie somewhere between 2.5 and 3. So we arrived at a rough estimate of the range in between these values will lie. That is, root 2 will be somewhere between 1 and 1.5 and root 7 will be somewhere between 2.5 and 3. But we don't know how far we can go to the left of 1.5 or to the right of 2.5. But we can choose a number between 1.5 and 2.5, which will definitely be between these two values. So we can choose any number between 1.5 and 2.5, 1.6, 1.7, 1.8 and so on. It could also have multiple decimal places, but it should have fixed number of decimal places. So any number between 1.5 and 2.5 can be chosen as a rational number between root 2 and root 7. So the method here is to find the perfect squares closest to the number to determine a range in between the value will lie, then choose its midpoint to get a more precise range, and then find a safe range between which we can choose a rational number which will lie between these two values. Now that we've covered previous year questions from the chapter Real Numbers, let's move on to the next chapter, Polynomials, which will be covered in the next video.